All right, guys, we got to talk about the difference between a vertical stretch and a vertical shrink when you're graphing your functions today. Here we go. Anytime that you've got a number right here that's greater than 1, that's the rule. Greater than 1 means your graph is going to stretch. Anytime your value right here is between 0 and 1, say a fraction, 1/5, 1/4, 1/3, a fraction sitting right there between 0 and 1, that shrinks your graph down. So today you got to do some labeling, some describe them. Vertical stretch, vertical shrink. It's all sitting with that value right in front of your x squared. So between 0 and 1, it's a fraction, that shrinks it. Greater than 1, that's a number, that stretches it. One more on this, we can look at the reflections when there's a negative sitting right there. So let's say we have a negative sign in front of our x squared. This negative sign right there makes this a reflection. So if your value's negative, whether it's a fraction or it's a number, it's going to be a reflection, so in the x-axis. So if we had our parent graph, was right here, a reflection on the x-axis is just going to reflect it straight down, so it's going to look like that. So you've got a vertical stretch, you've got a vertical shrink that's going to happen. And then if they throw in a negative sign, you can also throw in a reflection with that. All right, let's look at these math problems today. 4, what do we got here? G of x, let's just put 1 in there. A negative 1/2 x squared. So we know our job. We see x squared. We know that's going to be a quadratic. So here's my parent function. So there's my parent function. Let's see what happens here. The 1/2 flattens it out, so it shrinks it down, and the negative reflects it. So when you go to graph this, it's a reflection that's been flattened, that's been shrinked, so it looks more like that. So this is my y equals negative 1/2 x squared, and this is just my y equals x squared. And I think when you run this in the book, they label it with f's and g's. So they call all the parent functions f, and they call all the new functions that you graph g's. I saw that. That might be a little easier for some of the labeling. All right, let's describe it. We had 2 things that happened here. First, the negative sign hits, so that guarantees it's a reflection in the x-axis. So the negative sign makes it a reflection, and then you've got to decide vertical shrink or vertical stretch. But it's a fraction right there that shrinks it. So this is also a vertical shrink. And then the fancy way to say this is with a factor of 1/2. So this covers the negative sign, this covers the 1/2. It's graphed it, parent function, labeled it, described it. We're good at this. Let's do another one. All right, let's do number 5. Let's throw another function up there. Let's do a stretch this time. How about 3x squared? Okay, so we see the x squared. We're pretty good at the parent function. So that's just y equals x squared. There's a 3 sitting in front of this, which means it's going to stretch. So it really stretches my graph up. So when I go to graph the y equals 3x squared, it's going to look like this. Let me get the other thing out of the way there. It's a little easier to see that. So there is my parent function. Here's my new function. Now I just got to describe what just happened. So do you have yourself a vertical stretch or do you have a vertical shrink? Question of the day, oh, we're stretching. So this is a vertical stretch, factor of 3. Okay, so it's back and forth today. Parent function, regular function, you got to decide what happened to it. Is it shrinking or is it stretching? That was 5, let's do 6. G of x is equal to 1/2 x squared. Uh-oh. Let's do a little moving on this thing. 1x squared plus 3. Okay, x squared. So we know what the parent function is going to look like. So here's y equals x squared. We've got that. We have two things that are happening to us. You've got the 1/2, which is going to flatten it out. It's going to shrink your graph. The plus 3 means we've got to move this up 3 spots. So on your graph, once, twice, 3 times. So when you go to start this one, you got to start at 0, 3, and it's a 1/2. So your parabola gets flattened out. So it's going to look more like this. So there's y equals 1/2 x squared plus 3. That's a really bad drawing. Sorry about that second parabola there. So we had to go up 3 and we had to vertically shrink it. So let's put both on there. Let's start with the vertical shrink, factor of 1/2. So we got the first part, and then up 3, it's a translation. We went 3 units up. So you had the double on this. Okay, let's do one more. Let's do one more for this set of examples. All right, number 7, g of x 1/4. Okay. Let's get our parent function down here. Yeah, that's not too bad. Okay, got the parent function in there. All x squareds, all parabolas today. Feeling good about that. We have a couple things that are changing our graph. First off, you've got a 1/4 there. So when you've got a 1/4, that's a shrink. It shrinks it down, it flattens it out. The plus 6 moves it. Now you're inside here. When you're inside that parentheses, that decides whether you're going left or right. And it's always the opposite inside here. So positive 6 means we're going left 6 spots. Oh boy, let me see if I can stretch this out 6 spots. So here's 0, 1, 2, 3, 4, 5, 6. So here's -6, 0. Now let's think about it. It's a parabola. I've moved it over, 6 spots left. The 1/4 shrinks it. So this parabola, 1/4, flattens out. Get that out of the way. So there's my graph. I've got 2 pieces to describe. So I have a vertical and a question of the day. Is it a stretch or is it a shrink? So this one's a fraction. It's a shrink. Factor of 1/4. And then we did move this guy. We moved him 6 units to the left, so it is a translation. We went 6 units left. So on a lot of these problems, you get the double. You gotta shrink it or stretch it, and you gotta move it. So be on the lookout for reflections, shrinks, stretches, translations, graph, parent graph, describe it, 3 parts. There you go.